Hi guys, I welcome you all to my channel CSNet Lectures. So in this session we are going to discuss about Prim's algorithm, right? So this is one of the important type of spanning tree construction, right? So in the last class we discussed about Kruskal algorithm and how we are implementing it and all those things we discussed, isn't it? So now we are going to start up with Prim's algorithm. And friends, I request you all to please subscribe my channel because it will be a great motivation for our team. Right? So now we can go for this topic. So what is a Prim's algorithm and how we are going to implement it, right? So it is similar to that of Kruskal algorithm, but only one difference is being present over this algorithm. So what is the difference? That I am going to tell it to you, right? So how we are going to implement this algorithm is we are going to select the edge that is adjacent to the vertex in a connected manner, that is in sequence manner. In Kruskal algorithm what we did, we were randomly selecting the edges without considering the sequence, right? So but here we are going to select the edge that is being in sequence, that is all the edges what we are going to select is going to be in a connected manner. Okay friends, so please keep that in mind. So now we are going to implement the Prim's algorithm, and another one point is same as that of Kruskal. It is nothing but we are going to select the edge in such a case that no loop has to be formed, right? So these are all the things that we are going to follow in implementing the Prim's algorithm. Okay, so now I am going to tell you the steps what we are going to follow. It is similar to that of the previous algorithm type, right? So now what is the first step? We are going to start from any of the vertex, right? Suppose if the vertex is given, that is the vertex what we are going to start up. If it is given in the question, you can start up with that, no problem. Suppose if they didn't mention the source vertex, we are going to select the source vertex, that is we can use any of the vertex. So if I am going to select this as a source vertex, I am going to find the edges that are adjacent to that particular vertex, right? With the minimum weight, we are going to select that edge. After selecting the edge that has a minimum weight, we are moving to that vertex, right? So now this is your current vertex, not this. So from this vertex, we are going to find what are all the edges that are being adjacent to that vertex along with the edges of the previous vertex. Keep in mind, we are going to find the edges that are adjacent to the current vertex along with that of the previous vertex. Okay, those edges we are going to find, and then what we are going to do, the minimum weight that is present between that vertex and the previous vertex we are going to select. Okay, that is the thing, we are going to find the difference between those two algorithms. So this is a very important point, please note it down. Okay, so this is the process that we are going to follow in this algorithm, right? So now we will go for problem solving. So friends, this is a given graph. So we are going to convert this graph into a spanning tree, and we are going to find the total cost needed to travel from any of the source to destination. So since here they have not mentioned the source vertex, I am going to select as A. Okay, so start from A. So this is my source vertex, right? So this is my source vertex. So from A, find what are all the edges that is being adjacent to A. So I have A to B and A to C, right? So from this, which is having the minimum weight, so this is having the minimum weight, right? So now I am going to select this. So friends, now I am going to draw this because we are going to calculate the overall edges of the current vertex and the previous vertex. In order to have no confusion, I am going to draw here, right? So now this is my solution. So from A to C, this is my selected edge. So now this is my current vertex, isn't it? So now this is my previous vertex. So now from C, please make a note. So from C, very important point. So from C, find the edges that are all adjacent to C. So from C, find the edges that are all adjacent to C. So it is A to B, C to I and C to F. Then from the previous vertex, this is the previous vertex of C, isn't it? what are all the edges that are unselected. So that also you should have to see for the weight. So 10, okay, so 10, 6, 6 and 6. So if you find, we have 4 values, okay, so 10, 6, 6 and 6. So this is for A and this is for C. See, for A, this is the only unselected edge, so that also I should have to take it into consideration. And for the current vertex, I have 3 edges. And if you see 10, 6, 6 and 6, right. So among this, this is having the minimum weight 6, 6 and 6. So which edge I should have to select? So I can select any of the edges because all are holding the same similar weight. So for example, I am selecting this. You can select even this, right? This is having the minimum value. So I am selecting this. So I am going to move from C to F, right? Wait a minute. I need space, no? So I will draw like this. So C to F. So C to F I have drawn. So this is the next vertex edge that is being selected. So now from F, what are all edges that is being adjacent? So this is my current vertex and this is my previous vertex, right? So from F, what all the vertex that is being adjacent? Edges that is being adjacent. So this is adjacent, isn't it? So for F, this is adjacent, that is 3. And for F, what is the previous vertex? C is the previous vertex. Okay, so what are all the unselected edges that are being adjacent? C to B, C to I, isn't it? So the values are 6 and 6. Now from this, select which is minimum. So 3 is minimum, isn't it? So now I am going to draw this one. Okay, so F to G. Friends, are you all able to follow? So now this is the edge that is being selected. So this is the edge that is being selected, I have drawn. So now this is my current vertex and this is my previous vertex. So from G, what are all the edges that is being adjacent? G to E, G to H. So 2 edges are adjacent. So what are all its values? 4 and 1. Okay. So for G, what is the previous vertex? So this is my previous vertex. So from F, is there any unselected edge that is being present? No. So you can leave it. So among 4 and 1, which is having the minimum weight? So this is having the minimum weight. So I am going to select this. Okay. So G to H. Its value is 1. Right. So now over. Friends, are you all able to follow? Slight differences between that of the prims and cruscellus. Here we are selecting the edges of previous and current. That is the thing you should have to keep it in mind, right? And we are moving in sequence. Okay, now this is my current vertex and this is my previous vertex. So from G, what are all the edges that is being adjacent? So this is adjacent, that is 11, right? So now H to I is adjacent. Any other vertex? No. Any other edges? No, because this is visited. Leave it. So for H, which is a previous vertex, this one G. So from G, what all unselected is present? So this is the only one edge that is being present, right? So mark as 4. See, from G, this is the edge that is being unselected. So mark as 4. So among these, which is having the minimum weight? 4. So 4 is corresponding to G. Okay. So 4 is corresponding to G. So from G, draw to E. From G, I am drawing to E. Okay friends, are you all clear? Is it clear for you? So now right. So now E is my current vertex, right? So from E, what are all the edges that is being adjacent? Let me mark here. From E, what are all the edges that is being adjacent? So E to B, right? So E to B. Is there any other edge? No. Let it be 8. Now, what is the previous vertex? So this is my previous vertex. Friends, please follow this. I selected for E, current vertex. The previous vertex is G, because it is emerging from here, isn't it? So G is my current vertex. So from G, what are all the edges that is being present? So from G you see G to E I have selected, G to H also I have selected, then G to F all are selected. So no other chances, isn't it? So I must have to select E to B. There is only one option present. So mark. Right? Then each and every time while drawing the edge, please consider, please make a note that any cycle is formed, any loop is formed. Suppose if any loop is forming, don't select that edge, select the edge that is next of it, right? As no cycle is forming till now, I am continuously drawing. Okay, so now I have selected this one. Now, this is my current vertex, right? So, from this current vertex, what are all the edges that is being adjacent? So, 10 is adjacent, right? And 6 is adjacent, right? So, for E, is there any edge that is being unvisited? See, from E, this is visited, isn't it? So, this is also visited. Only left out edge is E to H. That is 11. Now among this, find which is having the minimum weight. So 6 is having the minimum weight, right? So B to C. B to C I am having the minimum weight. Suppose if I draw like this, after selecting this, if I draw this as my edge, you see a cycle is being formed, that is a loop is being formed. So you should not select this. Okay, so you are not going to select this, right? So among 10 and 11, find any other edges being present. So for 10, B to A. So B to A, do you have any edge? Do you have any path? So B to A, there is a path, right? If I select this also, you see we are getting a cycle. So you should not select this. Okay, so I am not going to select this 10 also. So now for 11, this is the path that is being present, isn't it? So from E to H if I draw also, I am getting the cycle. So I cannot able to select that edge. So leave this. So now what to do? We cannot able to traverse further, isn't it? So now what you must have to do is take the next previous vertex of E. Take the next previous vertex of E, it is G. Okay, so from G, you just find what are all the edges that is being present. So from G, if you see G to G to H, it is selected. Then from G to E also we have selected. Is there any other edge that is being present? No, this is also selected. Friends, are you all clear? Suppose if there is no edges present, we are moving backward through one previous vertex. We are moving backward through one previous vertex until an unselected edge is being present. Okay friends, this is the point. Please make a note of it. Right. So now from G also there is no edge. So now what is a previous vertex? F is my previous vertex, or you can select even H. So F is my previous vertex. So from F, okay, so from F you see, is there any edges that is being passing? So all are selected. See, all are selected, so I cannot able to see. So now you see for H. So if you see for H also, is there any edges that is being unselected? This is being selected. So only one edge is being present. So from H to I. Okay, so from H to I there is only one unselected edge. So now shall I draw? Yes, I can draw. So from H to I can draw and mark it as 5. See, I can also go in this manner, that is the previous vertex that are present for the respective G is H or F. Since there is no adjacent edges that is being present, I am selecting the next previous vertex which is being H. So it's, in that place there is a path, so I am drawing it. Friends, are you all clear? So now if you see, all the edges, all the vertices have been connected with no cycle formation. Friends, are you all clear now? So now this is the resultant spanning tree which I have got for this graph. Friends, so this is the way I must have to solve for this algorithm. Okay, so now I am going to find the weights, addition of weights for this respective graph. So now shall I add? So if I add, I will get 9 plus 6 plus 3, then 1 plus 5 plus 4 and 8. So now if you add, you will get the overall cost needed to travel from source to destination. So 9 plus 6, 15, 18, 19, 24, 28, 28 plus 8. So the value is 36. Okay friends, so this is the way you should have to solve. Now if you use the same technique for implementing Kruskal algorithm for this graph, you will be getting the same answer, right? So friends, this is your time complexity of both the algorithms. So please make a note of it. So this is your average time complexity. That is the time complexity of Kruskal algorithm. Okay. So O of V plus E log V, or you can tell that O of E log E. So what is V plus E? So V plus E is nothing but from the vertex we are selecting only one edge. So that is being represented. So for Prim's algorithm, so you have the same time complexity as O of V plus E log V, and this is another time complexity, that is O of E plus V log V. Okay, so this one is used if they have asked in the question as what is the time complexity of binary min heap. So this is for binary min heap, the time complexity is this one. If they have asked for Fibonacci min heap, Fibonacci, for that one you can use this or this one, right? So for binary min heap, the Kruskal and Prim's algorithms time complexity is this one. For Fibonacci min heap, the time complexity is this. So you must have to make a note of it, friends. So these are all very important questions that they may ask in MCQ. So now we have discussed about two types of algorithm in spanning tree, then how to construct it and so on. So for the same question which I have given in the last video, you please try it out for Prim's algorithm and you just share the answer. Okay friends, and I also tell you that both answers will be of same one, because for both algorithms we are finding the spanning tree, okay, with minimum cost. So when you construct and see for both the algorithms, you will be getting the same answer, right? So you just solve and give me the answer in the comment section, right? So we will meet in the next video. So bye.